Okay, before looking at the cosine Maclaurin polynomial on page 3, I want to make one comment about the sine Maclaurin polynomial. If you recall from your study of trig, you remember that sine is an odd function, right? So let me just show you the sine graph. And I gave it a nice window. And so I just have it as y is equal to sine of x. And then my window is just set at negative 2 pi to 2 pi. And then my x scale is a pi over 2. And my y min and my y max is negative 2 to 2. And so you get this nice looking graph. So the way that you can tell that something is an odd function is graphically it has rotational symmetry of 180 degrees. So if I take my calculator and I turn it upside down, so here we go, I just turned it upside down, you get the exact same graph, right? That's what's meant by having an odd function. And so if you look at the Taylor or the Maclaurin polynomial for the cosine or the sine, you can see that you have all odd powers, right? So this is x to the first power, and then you have x to the third power, x to the fifth power, x to the seventh power, and this is a general x to the odd power. And then it just alternates signs. So it starts with a positive, negative, positive, negative, and so on. And that's why you have a negative 1 raised to the k power. All right, so for the cosine, if you could actually just turn off the video, and I want you to formulate the cosine the way that we did for sine. Okay, so turn it off, and then I'd like you to look at the work afterwards. So for the cosine, I'm going to use the same procedure. I have f of x is equal to the cosine of x, so f of 0 is equal to 1. And then f prime of x is negative sine of x. And then I just keep writing out my derivatives, negative cosine of x and then positive sine of x. So you can see that it goes 1 and then it goes to 0 because it's going back to the sine, and sine of 0 is 0. And then it's a negative 1 and then 0. All right, so then if I write out my Maclaurin polynomials on this, the first one is going to be 1. And then the first order polynomial is actually the same thing as the 0th order. And so it's just going to stay as 1 because you're just adding on 0. And then the second order is 1 plus 0. And then you have a minus 1 over 2 factorial over x squared. And then the third order is this. Fourth order is this. And then the fifth order is this. So you can see that the first and the 0 and the first one is exactly the same. The second and the third are exactly the same. And then the fourth and the fifth, I think I said that wrong. The second and the third are exactly the same. And then you have the fourth one that's going to be same thing as the fifth one. Fifth one will be exactly the same. Okay, so I think I actually wrote this out wrong. And so this should not be here. So P of 6 of x is going to be this, and that's going to match up with P of 7. Okay, so the general on this is you have every even that's going to be 1. So it's going to start off with 1. So it's 1 minus 1 over 2 factorial times x squared plus 1 over 4 factorial times x to the fourth, and so on. So the general term on this is negative 1 raised to the k power. So this is your sine alternator. And then you're going to do every even, right? So this is x to the 2k, and then you have 2k factorial, right? So this means that it's going to be all even. And so if you recall that cosine is an even function. So if it's an even function, let me just put that in here. So you have cosine is an even. So even in terms of symmetry means that it has a reflectional symmetry about the y-axis. So this right here, this line right here, is going to be the line of symmetry, and anything to the right and the left of it are exactly the same. Okay, so if you look at that, and then in relation to this, just to see the pattern on this, here you have P sub k, 2k plus 1. Okay, so if you look at your general term, it's going to be 2k plus 1 factorial. Down here, it's a 2k factorial. Right, so this is the odd, and this right here is the even. In fact, I'm going to write that up. So this is the odd function. And then this right here is the even function. So if you remember your study of even and odd functions, even has powers that are 2, 4, 6, and so on. And so the uh, n behaviors are going to be the same. So if it goes positive, it's got to go positive in this direction. If it's negative, it's got to be negative. And that will correspond with what cosine is. And then for the odd function, they go in opposite directions. So if it's positive infinity to the right, it has to be negative infinity to the left, and then vice versa. Okay, so that is the Maclaurin polynomial for the cosine of x.